Okay, so to solve a system with three variables, we're going to use the same steps we use with two variables. We just have to use them many times. You want to find a letter to pick on. You want to find a letter that you want to eventually cancel out into nothing. Um, I think x might be an easy target because I could multiply this by 2, or I could multiply by -2 to make it cancel out down here, or I could just subtract these two. I think my goal to start off is to smush this system down and get rid of the x's. So the reason why that's going to be helpful, the reason why x is going to be a good one to choose is because I get to multiply or divide these equations by whatever number I'd like, and it's still the same equation, right? So I'm going to multiply this bottom equation by -1, and I'll keep the top equation the same. So I'm just looking at these two right now. So I multiplied everything by -1 in the bottom equation, and I did that so that when I add these two equations together, my x's are going to cancel. So you'll want to manipulate them, and I teach it so that you're always adding. Some teachers will say, hey, you can just subtract the two equations, but students always lose a negative sign. So if you do it this way, you're not going to lose a negative sign. Set it up so that you're always adding the two equations to make one of the letters cancel out. I multiplied this by -1. That way, when I add these two equations, they cancel out. And 8y plus -y makes 7y. -2z plus -2z makes -4z. And then 30 plus 6 makes 36. Okay, then we're going to do the same with another pairing of equations. We'll use this top equation and this bottom equation. In order to make the x's disappear, I can multiply this top equation by -2. Sorry, I had to pause it there. So multiply the entire top by -2. That way we're going to have a positive 4x on top of a negative 4x, so they'll cancel out. Multiplying everything by -2 in the top equation. And then I'm copying on the bottom equation. We don't want to do the same equation twice, the same pairing of equations twice. Okay, so if I add them together, the x's cancel out again. Okay, and so now we have a system of two variables. So this is back in a realm that's much more comfortable to us, right? So we can solve for y and for z and for this this system. Putting this one on top, I don't know why. Z looks like an easy target. If I multiply the entire top equation by 4, then I'll get that to cancel out. I don't know what 62 times 4 is without thinking about it hard. 248. That's -248. Okay, and then if I add those together to use elimination, I get -53y. Then we get, oops, it's -248 subtracted by 36, that's -212. So to get y by itself, I'd divide that 53 from both sides. So the -53 from both sides. So I should get y is +4. So once you have one of the variables, it's a cascade effect with all the other variables. You can plug this back into this equation up here or into this other smaller equation over here. Either one should give you the same answer. If I plug 4 in there, it's -60. Separate these. So add 60 to both sides and get z is -2. And then plug both those answers into either of the equations you have up here. So I'll plug it in up here and into the bottom equation. So I don't know what x is. I know y is 4, so +4. And then -2 goes in for z, so this is -3 times -2. So -3 times -2 is +6, so 4 plus 6 makes 10. So subtract that 10 from both sides. Divide -4 from both sides, so x is 3. So there's our solution. We got 3 comma 4, comma -2. That's our x, y, and z solution. I did that kind of fast because I do this a lot. You'll want to go slowly. It's really easy to just drop one sign, to add instead of subtract, and then one mistake in this step makes every other step meaningless because now you've got something wrong here, and it stinks when you realize it. But okay, you can check it too if you want. Plug 3 back in. So this is -6 plus 4 is -2. -2 plus -4 is -6. That checks out if I plug in that equation. But